some of which they believe in, some of which they don't. But the bottom line with factoring, every time I look at a factoring problem, especially those that immediately pop into my head of what to do, I basically, and listen, this may flow through my brain in an instant. Like I might just be like, and then going to the problem. But essentially I'm doing this. This is kind of a rough thing, but first thing I look at without fail, is there a GCF? Is there a greatest common factor that I can factor out? So if so, factor it out. I'm not saying if you don't factor it out that you aren't going to get to the correct factorization, but if you don't, it's going to be much harder. So take out that GCF immediately, then look to see what is left if you've got a shot. Next thing, because there's much more likelihood of having 3 or more terms than there is just 2, I kind of look at it and say, if there are 2 terms, if it's a binomial, if a binomial, is it a difference of 2 squares? If so, use your difference of 2 squares rule. Is it a difference or a sum of 2 cubes? If so, use those rules. Or is it a weird, tricky factorization? And those are very much less common, like something like x to the 7th plus x to the 7th, or x to the 9th minus x to the 9th. We talked about those. It is possible that that might pop up on your test. It is certainly not going to make the difference between an A and a B unless it's like between a 91 and an 89. But it is something that I would probably ask you. Then there's a whole page that talks about those little tricky ones. But I don't know that I've ever seen it outside of the math tournament on anything beyond this chapter. Okay? And that takes care of binomials, which again, difference of 2 squares, difference of sum of 2 cubes, that's typically where you're going to live in binomials. All right? Next thing, is it a trinomial? Now, if it is, to me, it's worth checking real quickly to see if it's a what?
Perfect square.
Yes. Check to see if it's a perfect square. Because a lot of times, is it a perfect square trinomial? If it is, a lot of times the lead number is like 36 or 25 or 16. And then the last number is something like 111 or some other 81, 36. If the number at the front and the back are perfect squares, and then that middle number checks your little check, right? Remember that check, square root of the first, square root of the last, double it. If that's the middle term, right, and the lead term and the end term are both the same sign, if all those checks, it's probably a whole lot easier to factor as a perfect square trinomial than to use the magic number or the guess, check, revise method. So if it's not a perfect square, then you use that guess, check, revise, or magic number. What did Miss Tyree call it again? Didn't she call it something like
Long trinomial.
Long trinomial, short, or whatever, something like that? Whatever, I don't care what name you call it. I'm not going to say, hey, what are the 2 rules? I just want you to have a game plan. And I normally do guess, check, revise for me, because I can check those in my head quickly, but if you're more of a visual person, you need to see it. Sometimes the magic number method's great, but I mentioned to you guys the magic number was great when your lead number was like maybe like a 12x squared or an 8x squared, where there's lots of different options for those 2 lead terms in the binomials. Well, the magic number method takes away the guessing and the checking, because you can just multiply those 2, write out all the factorizations, and find the one that, when you look at the factorizations, find the one that adds to give you the middle term, and then just start the process. So it takes away some of the guessing and the checking. Oh, that didn't work. And you keep checking the foil. You might have missed one, forgotten one. Takes away that process. So some people find comfort with this, but I can tell you moving forward, most of the time you factor in calculus, it's like x squared minus 5x minus 6. And the guess, check, revise method is just pretty easy. It just saves you time, and time is a deal on the AP test. So if it's a trinomial, one of these, it's gotta fit the bill there, or it's prime. And then if it's not a trinomial, it's a what? 4-term polynomial. So if, if a 4-term polynomial, what did I say to check first? I said it's rare, but if you're going to factor it 3, group it 3 and 1, what would have to immediately happen? Three of the 4 terms that have to be perfect square trinomials, if you're ignoring the signs, because the signs might not be positive. But 3 of the 4 would have to be perfect squares, and then the one that's not a perfect square would have to fit what? It would be the what? The middle term of the 3 of the trinomial. And then when you put it in the middle and then arranged it to make sure it works, that trinomial has to be a perfect square trinomial. And then the other one has to be a perfect square. The single term has to be a perfect square. And it has to be a minus in the middle. And if you can't make that happen, then you have no hope for a 3 and a 1. So most of the time you look at the 4 terms and you're like, oh, there's no perfect squares. Well then, there's no way it's going to be a 3 and 1 grouping. Right? And then, so most of the time, you get to a 2 and 2. That's what I call it, grouping. So I usually check the 3 and 1 real quickly, rather than spend all that time checking the 2 and 2 and then going, oh my gosh, it's not even a 2 and a 2. Because it's real easy to check for the 3 and the 1. The 2 and the 2, it may or may not work. But man, on this test, probably is going to work one of the 2 ways. I mean, I have totally put questions on there that are prime that really look like they group each ways. But that's really just sometimes you put tricky problems on there. And then if it's not a 4-term polynomial that's bigger than that, we haven't learned strategies on that yet. Now, it's possible that you have a 5-term polynomial, and if it was a 5-term, I would probably think it probably 3 of them grouped together, 2 of them grouped together, but I don't even have a memory of that. Like, it's possible, I mean, it is possible that when you group them, you go, oh my gosh, it does have a common factor that I can take out. But it would have to be a unique kind of question for that to happen. Like, here's an example. Like, what if I had x squared plus 6x plus 9 minus x squared? How about this? Now, this is a little lame because you'd probably go, I'm just going to cancel that out. So I'm a little desperate here, but assuming it is technically an unsimplified 5-term, like if I factor this into x plus 5, x plus 1, right? And then if I pulled a negative out of this, this would factor into x plus 5, x minus 5, with the negative there. And then look, I could factor out an x plus 5 out of this. And when I factored it out, I would have an x plus 1 minus an x minus 5 left. But again, this is a terrible example because you probably wouldn't do that, would you? You'd probably add these 2 terms, and then you'd end up with the trinomial. And that trinomial would factor really nicely as, actually, the trinomial wouldn't even factor, it would just simplify into something pretty nicely like 6x plus, 30? I guess you factor an x out, that's 6x. So whatever, this is kind of lame, I guess, but I'm just showing you that it is possible for there to be a 5-term polynomial that may factor creatively. But I don't see me asking you something like that on this test. Maybe as a bonus, I don't know. Are y'all with me? So literally, and I'm not saying I go, okay, rule number 1, but these are all burned in my brain. That's kind of the order I look through. So when I look through a problem, it's kind of like, GCF, no, it's a trinomial, and I jump to whatever works for it. You know, GCF, yes or no, there's a GCF, oh, it's a binomial, make it fit. GCF, oh, 4 terms, which one? Let's check 3 and 1, if not, let's group it 2 and 2. So, but that's my thinking almost on all of these. And you could look at it as 3 rules, you could look at it as 7 rules if you want to break these all up, or 9 or whatever. Y'all with me? Is there any particular one of these you want to talk about before we jump to what we're doing today? Or is there anything about solving equations you want to talk about that we talked about on Friday? Or that you watched the video on Friday? What was the big key takeaway from Friday's video? And I was saying it over and over. You gotta what? If you're not watching the videos,
have the equation all at once.
which makes it
Oh, it has to be equal to 0.
Equal to 0. And if it's not equal to 0, even though it may look really pretty,
You can't solve.
you can't do it. If it's x plus 1 times x minus 2 times x plus 3 equals 7, then all that factoring was for naught, because it's not factored. Because as soon as you move that 7 over, now you have minus 7. So even though those are grouped nicely, it's not factored, because factoring, if you have something like this, that's not factored, because factoring means all you have, like if I say factor your age and you're 15, 3 times 5 is a factorization of your age, right? Is this a factorization of your age? 3 times 4 plus 3, if you're 15. No, if you're adding or subtracting anything to the product, it's not factored. And you are adding or subtracting something to a product. So really, your only hope is really to take this, multiply it all back together, and start back over. And your only hope here is to multiply this all back together, and then hopefully start back over, although this is prime, but on one that I gave you, it would not be. Y'all seeing that? But you gotta have it equal to 0. That's just the big takeaway, that whole 0 product property. And if you didn't watch that video, you gotta go back and make sure you watch the videos. I have some guys that I know aren't watching anything, and it is not ending well for them. It's really, I think it's not gonna be long before they bring all y'all back. Like when I say not long, I mean, it may start next Thursday.
Mr. Cooper said y'all are having a staff meeting today. And
Yeah,
he's
I
like,
think
it's like 3 weeks, and then they're going to bring us all back on Wednesday.
I don't even know if it's going to be that long, but it might be. He doesn't know much. I talked with Dr. Barnes. I've talked with Patrick Chappell at the central office, and they just said it's coming sooner than you might think. So this might be the last Wednesday meet we have. I know the next Wednesday we have the PSAT, and then you guys come to class. You're going to come on Wednesday, and then Blue's going to come on Thursday, and then y'all don't even come on Friday because the parent-teacher conferences. That's next weekend, and you'll have a long weekend, Friday, Saturday, Sunday. But I wouldn't be surprised at all if maybe next Thursday or Friday you were all back together, or maybe that following Monday you were all back together. Wouldn't surprise me a bit, but I don't know. Who knows? I have certainly not been told anything directly, except it's coming sooner than you think. All right? Okay, so here's what we're going to do today. It's and this is actually, believe it or not, an introduction to calculus. It doesn't seem like calculus at all, but we're going to be looking at things called critical numbers. And the book, I don't even think refers to them as critical numbers. They might, but it's been a while since I looked at the actual textbook. But in a critical number in calculus, you find places on the graph where behavior changes. Like it might be where a graph goes from like this, what we call increasing to decreasing. It might be a place where the graph changes concavity, like from concave up to concave down. Those are changes in a graph. And in calculus, we have different names for them. But here, we're looking for places where the graph is positive or negative. Now, if I say a function has positive values, like think about this. If I were to give you some random function, and you were to graph it, okay? And when you graph this, it looks something like this. Okay, I only know that because I kind of factored it and found the intercepts and whatever. Say it looks something like this. Where would the function have positive? Where would the y values be positive? Like, you got all kinds of points on this graph, right? Which ones have, say it again?
Above the x.
Above the x. Positive y values, those are positive y values, right? Because I went over there and then up, over there and up, over there and up, here, over there, up, over there, up. So positive values on y would be here. Where are negative y values? Right in there. Where are 0 y values? At that. Well, what I'm going to be doing today is I'm going to be asking you, not actually where is this function positive, because if I did, you would say, oh, the graph is positive, this actual curve, the y values are greater than this, not just where it's positive, I'm not saying that, but I'm saying where is this greater than or equal to that? Well, what did you do when you had a line that says y is greater than? What did you do? You shaded above. So this is bigger than that, not bigger than 0, but bigger than that where it's above. and you would come in here and shade above. All right? Which is different than saying where is the y value is positive. Okay? Y'all track with me? Don't get confused by this, right? If I said where y is less than all of that, then you'd shade below. It's the same thing as if I say where is y bigger than this? You'd shade above, right? And where is y less than? You'd shade below. Now here's the difference. I'm not going to say f of x. And if I don't say f of x and include a y value, what does your graph become? It's not an x and a y anymore. It's just a... How do I graph x's? X's and y's I graph on a plane. X's I graph on
A line.
a number line. So this becomes this. Becomes a number line. So how do I think about that? Well, look, not a whole lot changes. If the graph is going to be shaded in between 2 points, I'm certainly going to need to check to see where it's shaded. But I also need to check where what? What does the -1 and the 4 represent? Do you think? Take a guess. The -1 and the 4 represent where this is, say.
The x squared and that represents the coefficient.
It does kind of seem like that right now. That's actually a pretty decent guess. It has something to do with that, I suppose. But if I were to, go ahead.
Where it's equal.
Where it's equal.
Oh.
These represent where it's equal. Right? Like, isn't a 0 less than or equal the same thing as an equal sign and a less than sign? And why they don't write it like that, I don't know. Just shortcut. Not that you're saving any critical time there, right? So the equal part, you just learned how to do it. How do you find out where a function is equal to 0? You factor it. X, 4, 1, negative, positive. All right? And then you set these equal to 0 and say, oh, that's equal to 0 when x is 4. That's equal to 0 when x is -1. And you mark the 4 and the -1. That is the equal part. Then, how do you deal with the inequality part? Well, if it was a function, I could go back and I was graphing the x and the y. I could go back. Remember what we did? You could pick a point and see if it was true, and then you could shade that direction. Or if it's y greater, you shade up, y less, you shade down. Well, look, I don't have to do that. I just pick an x value in the middle. Check that, or that, or that. So I'm going to come in here and just check values on either sides of these. Like, if you want to, there's -1, check a -2. If it's between -1 and 4, check 0. And I'll show you what I mean by check. If it's after 4, check 5. Are you with me? Because just like when you shaded a line, if it's shaded on one side, it doesn't really matter what point you check. Anything, if you check something right and it says it's true, you shade the whole side. So anything in between here, if you check that number in here and it makes a true statement, and I'm going to check it in here because I think it's even easier, and you'll see why in a second. But you're welcome to do that. If I pick a number like -2 and plug it in there, I get 4 plus 6 is 10 minus 4 is 6. Is 6 bigger than 0? Yeah. So if I pick something like that and it ends up being true, I'm going to shade it. If it's not true, I'm not going to shade it. So right here, if I plug, but I can also plug it in here. If I plug a -2 in there, what do I get? -6 times a, and what's a -6 times a -1? 6? Are y'all with me? So on this one, I think our original opponent said greater than, but whatever, we'll go with this less than. So right here, because it says less than, and I checked -2, and it made a true statement, I'm going to shade there. Sorry, I think my original one was greater than, because I shaded above. Sorry if I changed that on you. And then right here, if I pick a number like 0, and again, you can plug it there and get -4. Or you can go, if I plug a 0 there and there, I get -4 times +1 is negative. Is a negative right here? Is a negative bigger than a positive? Then don't shade it. And if I check a number like 5, 1, 6. 1 times 6 is positive times positive, right? Positive times positive is positive. Is that a true statement? Are positives bigger than zeros? Yes? Shade it. So really, it's the same thing. And if you had graphed, again, the original one was greater than or equal to. If you had graphed that, if it was an F, and you had graphed this, and you had shaded the line, graphed the line in there, and I'm like, where is Y less than? Where would Y be less than here? All of that, right? It'd be below the curve if it was less than. And if I get rid of the Y component, what do I have left? I have shaded to the right, shaded to the left. Same thing you see here. But I'm not dealing with Y equals. So the bottom line is, these are what we call critical numbers in calculus. Critical numbers in calculus are where the graph changes from increasing to decreasing. But in Algebra 2, we look at critical numbers as places where the graph changes from positive to negative or from true to false. Are you with me? Because you can see that this is true. These regions over here make it true. This region right here makes that false. And I'm trying to find all the values. But remember that means two things. Where is it equal? And I can factor and solve that. Where is it shaded? And I can check and get that. Now, what would you do if it was not equal?
You wouldn't fill in the bubbles.
I wouldn't fill in the bubbles. So when I'm actually factoring and solving, I'm not finding out where it's true. I'm finding out where it's false, but where it changes. And the way we show change is an open circle. It's like, all right, it gets right up to it, but doesn't include it. Not too bad? Now, you can imagine, to get to this part, what do you have to be able to do? Factor. And there are going to be plenty of times on this test where I check your ability to factor. But I want to be able to check your ability to do this. So most of the time on this test, I give these problems already factored to you. So let me give you an example of what you might see. Solve. All right, so you have an equation that's already factored for you and set equal to 0. If it wasn't set equal to 0, that'd be a mess, because you'd have to multiply all this chunk back together, add that to the constant, and then refactor it, and that'd be a 4-term polynomial most likely. Would be no fun. I won't do that to you on a problem like this. So what do you do to do the equal part? What are my critical numbers? Are the places where I'm going to mark the number line? 3, 1, and -2. So I can go right away and mark the -2. Make sure you get these in order. It's not going to. And by the way, don't spend too much time on your number line. You don't even have to space them well. Just -2, 1, 3. That's fine. And should these be colored in or open circles? Colored in because it's equal. So this is where they're equal, at 3, 1, and -2. And that'd be it. If I was just solving where there's an equal sign, I'd say, hey, your solution's -2, 1, and 3 in brackets, and I'd be done. But I'm checking an inequality. So now how do I go back and check the inequality part? I got to guess and check in all 4 of those regions. So what do you want to check for this region? -3, great idea. So again, do I care about the actual value that occurs at -3, or just whether it makes this true or false?
Just whether it makes it true or false.
Whether it makes it true or false. What's going to make this true? If the stuff on the right is what?
Any negative number.
If any negative, it's going to be negative, right? Now, it doesn't mean that the number I check here has to be negative. All right, I'm going to check a -3. But when I plug that negative in there, if my result is negative, then that would be a true statement. I'm going to shade this. So here we go. I'm checking -3. Okay, so let's check it. If I plug a -3 in there, what do I get? A negative. If I plug a negative in there, what do I get? Another negative. If I plug in a -3 in there, what do I get?
Negative.
A third negative. When I multiply 3 negative numbers together, what does that give me?
Negative.
A negative. Are negatives smaller than 0?
Yes.
Well then, let's shade that. All right, let's check the next region. Pick a number in there. I love the 0. Plug a 0 in there, what do you get? 0 in there, what do you get? 0 in there, what do you get? What does a negative times a negative times a positive give me? A positive? Well, then I'm not shading that because positive numbers are not smaller than 0. Right? What else? What about here? 2. What happens when I check a 2 in all three? I get negative, positive, positive, negative, positive, positive. What does that give me when I multiply them?
Negative.
A negative. Is that true?
Yes.
And then finally, what happens when I check a 4 in there? Plus, plus, plus. I'm not shading plus, plus, plus here. So it said to solve. It didn't say to graph. I just used the graph to help me. So what would your solution be? And if you put it in interval notation, what would your solution be? From negative infinity with the parentheses, comma to what? Negative 2 with a bracket. And then either union or comma. Either way, union's probably more fancy, but AP doesn't use a lot of unions. They put commas. And then what?
Bracket 1.
Bracket 1 to 3. But if I didn't say interval notation, you could say all the x's smaller than or equal to negative 2, or 1 less than or equal to x less than or equal to 3. They mean the same thing, but if anybody ever asks you for interval notation, make sure that you give it to them. Not too bad? All right, what if I throw you ugliness? And I say solve. Now, fortunately, it's already factored for us. And I'm asking you to find out where it's greater than. So since I didn't say equal, do I need to find these critical numbers?
No.
Yes, why? Because I got to put an open circle there. There's still the places where what? I go from shaded to non-shaded. So whether they're equal or not equal doesn't really matter. I still have to find what matters, but it doesn't really matter in terms of ignoring it. I still have to find where to put a closed or an open circle. So what do I get for these critical numbers here? What are my solutions when I set those each not equal to 0?
0.
Right, negative 2x not equal to 0 gives me x not 0. This gives me
X not 3.
x not 3. Be careful about those. This gives me
X
not negative 5, and this gives me, actually, let me change this last one. Change it to an 8. That'll be an easy change. Make it x minus 8. This means x what? Not 8. And if you forget and make those equals right there, as long as they come up as open circles in your answer, that's fine. So what am I marking here? I've got a negative 5 on the left, open, a 0, open, a 3, and an 8. And again, you don't have to be to scale. As long as you get them in order from left to right, you're fine.
Does it matter that that's squared?
It actually does, and you're going to see why in a second. But it doesn't affect if you do it this way every time, it's not going to affect anything. But it does mean something, which I'll talk about in a second. But if you don't pay attention to what I'm showing you, you'll still be fine on all your work. All right? Now, in reference to his question, and he was saying, does the square do anything? And a better question would be, does an even power do anything? Because you'll notice all these other ones have 1s, and those are technically odd. And you'll see that when they're all odd powers, like you saw here, 1, 1, 1, and nothing would have changed here if it was a 1, 3, 5. It would have still graphed the same way. What do you notice about the regions?
Every other.
They're always every other one. So whatever is shaded, it just alternate after that, right? A lot of people get sloppy and they just check 1 and go, it must alternate. I wouldn't do that because I'm a little more careful. But and you might have accidentally checked incorrectly, and if you checked it again, then you'd go, oh, wait a minute, what happened? Why didn't that alternate? Maybe you'd catch up careless error. But you'll see here, this does not alternate. And I'll show you why in a second. So right here, once I get those marked, what do we do? What are we checking to see if what? All of this is
Or positive.
Greater than 0. So this time I'm checking to see if all of that's positive. So let's check, say, -6. So checking -6. What happens if I plug a -6 right here in this term? That becomes positive. What about a -6 there? 3 minus a -6.
Positive.
Oh, another positive. What about a -6 there? Negative. What about a -6 here? And by the way, do I ever even need to bother checking into this term?
No.
Why?
Because it's always going to be negative. No.
Why isn't it positive?
No matter what I plug in there in the end, what do I do with it?
Square.
And what is squaring anything?
Positive.
Ends up making it positive, right? Because if it's positive and I square it, it's plus times plus, which is plus. If it's negative and I square it, it's negative times negative, which is plus. So you don't even have to check in that if you don't want. But again, you can keep checking. Plug it in there and you get negative something squared positive. And what does that mean if you have one negative?
Negative.
The whole thing's negative. Does that make a true statement?
No.
So don't shade it. What about here? What's a good number to check?
-1.
-1. If I plug a -1 in this first expression, what does that give me? Plus in that right there. -1 there. Plus -1 there. Plus -1 in there.
Plus.
A negative square, which is plus. So I got nothing but pluses. That must be plus. I'm definitely shading this thing. What about 0 to 2? I mean 0 to 3. What do you want to check? 2, 2 or 1, whatever. Somebody said 2. If I plug a 2 in there,
Negative.
2 in there,
Positive.
positive, 2 in there,
Positive.
and in the end it's always.
Positive.
And then what does one negative give me?
Negative.
Negative. Don't shade it. Now for those of you who got cocky and went, oh man, it always alternates. Look what happens when you check a number like 4. Negative. Negative. Positive. Positive. 2 negatives equal positive. Don't shade it. And then what happens when you check a number like 8? Hold on.
Wait, why is it not?
Wait a minute.
No, that's positive, and it's true, so I am shading, sorry. Right? Positive, true, shaded. Now, here's what happens. Look what happens when I check a number like 9. Check a 9 in here. Negative, negative, positive, positive. Still positive. Anybody got a guess as to why?
Because everything above 3 is positive? Wait, no.
Everything above 3, with the exception of 8, makes this positive. That is a true statement. But why? It may not be a great question I'm asking. Let me give you another hint. What did you learn about double roots? So if it was a function, which it's not, there's no y in there, but if it was, on functions, what happens on a double root? Instead of crossing through and being,
It hits it.
it bounces, right? So what if this was a y over here? If this would be y less than, wouldn't it? Now think about this. If it was y less than, the function's going to come down, bounce off the 8, but then cross through the 3, because that's a single root, cross through the 0, because that's a single root, and then cross through the -5, because that's a single root. And if I said shade where y is less than that, you would shade down, and what would you be hitting? That part of the number line, but then not that, right? And then that part of the number line, and then bouncing, and then more of the number line. But do you need to know that right now? No, because we're not even talking about y, are we? We just want to know where that's positive. So I don't need to know any of that other stuff. But if you're looking for an explanation as to why that happened, it really has to do with the fact that there are single roots and there are double roots. Now, that being said, can anybody come up with a little, if you want, you don't need it, right? We did it without any little rule. It's not like we do these every day where we need to know a shortcut. What could you say happens at the even roots? Instead of alternating, it repeats the behavior on either side. Odd root, opposite behavior. Odd root, opposite behavior. Odd root, opposite behavior. And I'm saying odd root not because I'm saying an odd power group. Odd power group, odd power, but on an even power, same shading on either side. And it'll be both be shaded or both not be shaded. That just has to do with this. Because if I change that to greater than, what do you think happens to this?
It
Kind of just reverses,
no,
doesn't it?
inverses.
Instead of doing that in the middle, now it's doing that. Instead of doing that here and nothing there, it does that. And instead of it being shaded on both sides, it's empty on both sides. So really, your final answer just ends up being those two things, doesn't it? Y'all follow me?
Yes.
But again, do you need to know that? It's not like I'm giving you 20 of these and you're like, man, if I don't remember that trick, I'll never get done on the test. Maybe that happens once on the test. Bottom line, check, 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 and you're going to be fine. Y'all seeing it? So, would any of these answers have changed over here if that was a 3 or a 5 or a 9? Why? Because when I check that and plug a negative in there, it's 3 negatives, and 3 negatives acts the same as 1. When I plug a 0 in there, I got 5 negatives. Well, 5 negatives acted the same as 1 negative. When I plug a -4, whatever in there, I got 9 negatives. Well, 9 negatives acts the same as 1 negative. So it really doesn't matter when they're odd. It just doesn't. If they're even, it basically takes them out of the picture and nothing changes there. Now you still got to mark the open parts if they're open or the closed parts if they're closed. Right? All right, one more and then I'm going to show you. Oh, running out of time. So what if I gave you this? So, where would the critical numbers, or where would be the places where this was equal to 0? Where would that occur?
0.
0? -3?
Positive 5.
Positive 5 over 2, because you'd have to add the 5 and divide by 2. And positive 1. Those are my critical numbers, so I'm going to go ahead and mark those in order from left to right. So a -3. Solid or dotted?
Solid.
Solid, good. Then a 0. Then a 1. And then a 5/2, which is like 2.5. Right?
How do you know if they're open or closed? Okay.
So if it's equal, you count them. On this one over here, it was not equal, so I don't count them. But I still use them either way because they're the barriers where it switches. And now I got to start checking. So let's check here at -3. I'm going to check -4 right here. Now, if I plug a -4 in right there, what happens to it when I square it? Times 8, still positive, plus. If I plug a -4 in there, what happens -4 plus 3? Negative. Negative cubed, doesn't change, it's still negative. -4 in here, what happens when I get -8 minus 5? Negative something, but I'm squaring it.
Yeah.
Positive. And if I plug that negative number in here, what's 1 minus a -4?
Plus.
Positive. So what happens if I get 1 negative?
It is negative.
It's negative. Do I want to shade negative here?
Yes.
All of that's smaller than 0? I definitely want to shade negative. Now here's where you can get really clever and never check another number. What do you know about -3? It came from a what? What kind of root? Even or odd? An odd root? Now at odd roots, do you bounce?
No.
No. And the only time I can get the same thing shaded on either side is if it's even. So if it's an odd root, what do you know must happen?
Not gonna shade.
It's not going to shade. So if you want to, you can say, I know that's not going to shade. Now, do you need to know that? In the time it just took me to explain it, you could have checked -1, couldn't you? Right? So you don't have to know that. But if that has an odd power, you know it's going to change. All right, so now I know it's not shaded here. Whether you check it or not. Now what do you know about 0? Came from that. Oh, wait. That's an even root. What happens at even roots? Bounces, which would be the same thing on both sides, right? So if it didn't shade here,
It's not gonna show that.
it's not going to shade there. So now I know it doesn't shade there. But guys, look, who cares? Check 1/2. If I check 1/2, I get positive. Positive. Negative squared, still positive. Positive. It's positive. It's positive smaller than 0. No, don't shade. Check all day. You don't have to know these rules. I'm just check, 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 and you'll always be safe. I'm just showing you something that you might be able to say in a second. So since that was even, I got the same thing on both sides. Now what about the 1? What was that? Odd root. So what should happen at 1?
The opposite.
Change. So if this was not shaded, this must be shaded. Right? And then what happens at 5/2? Squared.
Or
That's a
even.
double root.
Bounces.
So if it bounced there, what's shaded here would be also shaded there. So I was actually able to do this whole thing with only checking one thing. Do I advise you to do that? No, not at all. If I was giving you 100 of these, and you're like, dude, this is going to take me 10 hours unless I learn some tricks, I'd say learn some tricks. You might do a collective 10 problems in the next 2 years that are like this. Check, 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 check. And just don't worry about killing yourself over little extra rules. But if you'd happen to remember, oh, same behavior on these double roots, on these even roots, so the same behavior happens on either side. Same behavior happens on either side. So what would be my final solution here? From negative infinity to negative 3 with a bracket on the negative 3, union with,
0.
now, yeah, don't go 0 to 0 with brackets, it's just the number 0. Union with
1 with bracket.
1 to
Infinity.
infinity. If it goes right through the 5/2, do I need to break it up there? Nah, so go all the way through. But if it's not a point, I mean, if it's just a point, then just write the value down. Y'all with me?
Yep.
Okay, hardest thing I want to give you. I don't even know if I'm giving it. Tell you what, I got 5 minutes. Let me just throw something in. And remember, in your homework tonight, sometimes they're going to say to factor. So what do you have? I mean, sometimes they're going to say to solve and it won't be factored. So if it's not, what do you do?
Factor.
Set it equal to 0 and factor it, right? And then just be careful on the factoring. It's probably not going to be a big deal. Like I'm staring at one right now that I haven't had time where you look at it and you put it all on one side, you factor out the GCF, and you end up with like x squared minus 3x minus 10, a basic little trinomial with continue factor. And if you're totally lost in the factoring, just come see me after school, before school, and we'll address what you're having issues with. I get it. Every year I have people that have Pavlovian, fearful reactions to factoring, and they never get past it. Once you get past it, you're going to breathe and go, oh, this is not so bad. It may not be on this test, hopefully it will be. We can talk all you want. I'm here every day after school, before school. Yes? Question?
Oh, no.
Okay, so what if I gave you this? Same kind of thinking. What if I give you this, and I want you to think about what the definition means? People try to memorize this stuff. Don't memorize. The question is, what is the domain? Now, can anybody tell me what domain means in general? The x values that what? What do you mean work?
That like,
You're right, but what do you mean by it?
you get an answer that's like rational.
It's like
Actually, it doesn't even have to be rational, but it can't be, and we haven't technically talked about this, imaginary. It's not like, the way this number system will work, and you'll see soon, is they're either real numbers, and real numbers can be numbers like pi, or square root of 2, or 5, or 2/3, and then there's imaginary numbers that have eyes in them. So domain means, but they have to exist, right? What happens if I plug it in there and I get 5/0? Well, that's not a number, right? What's 5/0? Undefined. What happens if I get a number like square root of -7?
That's not exist.
Y'all learned that had an I in it. And we'll go back all through that again. So bottom line, if I want the domain, the domain for this would have to be numbers where I don't get what? And if I don't get i's, I don't get negatives. So what am I saying? I got to make sure that these are not negative. How do I say that with math? What can't be negative? This stuff. Now, the x value you plug in might be negative, but when you plug it in, you simplify it and it ends up being positive. So what can't be? This right here has to be what?
Greater than 0.
Close.
Greater than or equal to 0.
Or equal to. Because if it's equal to, what's the square root of 0?
0.
That's okay. You got an answer. What's the square root of negative 3? I did not get an answer. So I have to make sure for domain that this stuff on the inside is greater than or equal to 0, which is saying not negative. Well, now what do I have here? The problem we just did. I've been doing this all day, right? Factor it. Get my critical numbers. Mark them. Do I shade them? Yes, I do. And then all I got to do, since it's all odd powers, just check one. If I check right here, like I'm going to check negative 2 right here. I get negative times negative is positive. Is positive true?
Yes.
For this one? Yes.
Yeah.
Shade that, and if they all alternate, which they have to because there are no even powers, or just check them all, and it's only going to take you another 30 seconds. So, what is my domain? Everything from negative infinity to negative 1, or from 4 to infinity. That's not that bad, is it? But don't memorize. People are like, wait a minute, well, I got to make sure if I see a square root, no. Just think, anything under the radical has to be greater than or equal to 0. What if you had a denominator? What if this is your problem? And I said, what's the domain? Then what do? What can't it be?
0.
So that can't be 0? How do you say that? It's not an inequality. What would you say? That
Not equal.
can't be 0? Factor and solve, and then you say, hey, everything but those two numbers. We've done this actually before. I don't know if you recognize it. The only thing different is now I'm throwing you something squared in there so that you have 2 of them, and you got to check, check, check. So bottom line, guys, if you are ever solving an inequality and you have more than one x, then you can't just say greater than or equal to that x. You got to check, check, check on either side of these values to figure out where the shady stuff is. Hey, do the best you can on this. We'll see what happens. We're kind of winding down towards the end. And remember, we have today, tomorrow, I think we're reviewing, seems like we're reviewing Wednesday and Thursday because of, yeah. So really we have we got some math team level stuff to do tomorrow, which is nothing new. It's just a different look on stuff. Maybe some uglier looking factoring problems. Maybe some uglier looking these, slightly. And then we're going to do those, and we're going to review Wednesday on your own, kind of. If you have questions, you can phone them in, text them in, whatever, and test Thursday, Friday. All right?